Alright, so, what section was that again, I'm sorry?
3.1.
Number,
So like number
like, for
18.
example, 18?
Yeah.
Okay, alright, let's go through these. So let's see, 3. My eye is better, if anybody was curious, just to let you know. It just still looks a little funky, so. 3. What am I? 15. Oh yeah, okay. Yeah, this one's definitely tricky. Alright, so looking at number 15, I'm gonna do one like it. Alright, Jeff. Yeah. Okay. So looking at this problem, it asks me to evaluate that thing, right? And when students see this, I don't blame you, you're like, shit. Break it down to parts. Do I already know this for the problem I'm doing? Do I already know this? Yes, right? I already know that. What do I not know that this wants me to evaluate? What part of this do I not know yet?
X plus H.
Yeah, I don't know this piece, yes? You guys see what I'm saying? I know f of x. And here I know f of x, right? I know that already. So I can just throw that whole thing right there. What I don't know yet is this piece. All right, let me stop for a minute. Do you guys see that? I'm breaking the problem into parts, which is just about the best way to do math in general. I got this big ugly thing. Okay, this piece I know, sweet. This piece, I don't freaking know that yet. Somebody help me out, remind me, what is f of a for this?
3a squared plus a.
Yeah, right. If f of x is 3x squared plus x, f of a is 3a squared plus a. It's just plugging shit in, right? The letter x is totally arbitrary. We just chose it. Not because we were all pirates. There's actually a history behind why it's x. I'm not going to teach that. Now, you ready? So didn't I just put whatever the shit's here, I just put it there and there, bam. Yes?
Yeah.
Yes? All right, so what's f of Jeff?
Jeff squared plus
3 times Jeff squared plus
Jeff.
Jeff. Y'all with me? Functions are so freaking single-minded. They're just like, whatever you put in me, just put it in me. Just put it where the x is. So this one wants me to use, so I don't need this, I don't need this. I need f of x plus h. So now what am I putting in place of x?
X plus h.
So 3 times x plus h squared plus
X plus h.
x plus h. Do you guys see that? Function notation is so single-minded. Just whatever the shit's there, just put it in place of x. That's it. That's all it is. Let me stop for a minute, Art. You guys see that?
3.3
Probably
number
better than I
5. Maybe?
Hmm?
3.3 number 5.
Oh, all right. Let me add that. We're not done with this yet. Okay. Can you do anything with this?
You can
Distribute it.
distribute it.
Can I distribute a 3 right now? What's order operations?
Oh, first you gotta do whatever's in the.
Yeah, I gotta square this first,
Yeah.
right? So that's just foiling us out. Are you guys with me? Or are you against me?
Okay.
Down with Jeff. Let me stop for a minute. You guys see what I just did? Barely anything. Is everybody okay with this statement? If you're not okay, at least 7 other people are with you. So if you speak up, you'll be a hero. Does everybody see how I got this?
I see how you got that.
Okay, thank you. So again, help me out. If that's f of x, what is f of 2?
Well, that'd be like.
What do I do with the 2?
You square it, you put it where the X is.
Okay, so at this stage, we have got, so where's x in this statement? Where's x? Isn't it there?
Yeah.
And isn't it there? So f evaluated at x is 3 times x squared plus x. F evaluated at 2 is 3 times 2 squared plus 2. I mean, that's all function notation is. That is it. That is all that shit is. So real quick. If I had y equals x squared and I made an xy table, if I put a 3 there, what would you get here?
9.
Because you plug 3 in, right?
Yeah.
That's all this is saying. Plug a 2 in. See what you get. So that would be 3 times 4 is 12 plus 2 is 14. Is that cool?
Yeah.
All right. Do you see how I had to do work after I plugged the 2 in? I got to simplify it. So that's why it's actually really cool when the freaking thing's a letter. So where am I going to put w now?
3 times W squared.
So it'll be 3 times
W squared.
w squared plus
W.
w. That's nice. I'm done. There's no like terms. So it's almost kind of better when it's a letter. There's less to do. Okay. So let me make it even worse. What if it was f of a plus b squared minus c?
That'll be 3.
What are you going to put in place of x?
The quantity A plus B squared minus
A
C.
plus b squared minus c squared plus
A plus B squared.
a plus b squared minus. That's gross. Yes, everybody agree? That first step was easy as shit, though, right? You just had to take what was in the function and put it into the function. Just replace x with it. That is the fundamental idea of function notation. And I know you all know how to do that. Just some of you guys are kind of like, we forgot how functions work and what the hell they mean. It just means substitute. That's all it means. So what am I substituting in for this? I'm substituting x plus h in place of x. That's it. Just whatever's in there, you put it in. And again, when I have that kind of tone, I don't mean to make you feel bad if you still don't understand. I'm just trying to show you it is less than you think it is. It is so single-minded. Just throw the stuff in, yeah.
Can you do that?
Say again?
Can you do that?
Yeah, just a minute. Right? And then what can I do here?
Foil.
Foil it. X squared plus hx is plus 2hx plus h squared plus x plus h, right?
Yeah.
Now, I feel like some of you guys feel like, oh, shit, there's so many parts. I don't care. That's what it is. It's just a big old long thing. It's just a bunch of writing. At the moment, I don't care that it's a bunch of stuff. Right? And then I can distribute the 3. Is that cool?
Yeah.
Yeah, there. All right. So that is what f of x plus h is. So remind me, what did this problem need from me? It needed f of x plus h. Do I know that?
You do now.
No, I do. It needed f of x.
Already knew that.
I knew that from the beginning, right?
Yeah.
And on the bottom there's an h, okay? H, I know that. So now, all right, let me make sure, before I keep going. Is everybody with me so far? So look at this approach. This happens a lot in mathematics. There's a problem. It needs a lot of shit from you. Step back and go, okay, which pieces do I know and which piece do I not know? From the beginning, I knew what f of x was. Right? I'm doing a different problem, so you guys do this one. But for me, I knew what f of x was. Bam! Check. Then I had to figure out what the shit f of x... Oh, now I know what f of x plus h is. Check. So I call this the construction approach. I construct what the problem needs from me, and then I just put it in there, right? So now it needs me to figure out what? F of x plus h minus f of x over h. So what goes here?
All that crap down there.
Yeah, all that crap down there. This is f of x plus h, yes? So I just put blah. 3x squared plus 6xh plus h squared plus x plus h. Shoot, did I miss something? Oh, missed a 3. Over, oops, minus, what goes here?
That up there, 3x.
Now here, I'm gonna make a mistake. I have made a mistake. I made a mistake right there, I made a mistake.
You didn't, well.
I didn't subtract the whole f of x, right? I only subtracted a part of it. What's the problem need me to do? Minus the function. So minus the function. And then it's all over h. And then the top, do you see how you can distribute the negative? A lot of shit cancels. Do you guys see that? Do you guys see that? If I distribute the negative, doesn't that become minus 3x squared minus x? Is that cool? Do you see how the 3x squares? Die. Do you see how the x's? Die. Right? And every term that's left on top, what's true about every term that's left on top? Every term that's left on top has something similar. What do they all have?
It's divisible by h.
They all have an h. So can I divide each one by h?
Yeah,
Good.
6
So I get 6x, right? This h cancels.
plus 3h.
Good, I lose an h, right? Because when I divide, and then of course this
Plus
and
1.
this plus 1. Okay. You guys see that? That was one of the weirder problems. I will grant you that. What was the other one? So we just, since we're running 3-3, let's look at this one. Number 5, you said?
Yeah.
Oh, okay. Yeah, these get weirder. Alright, let me see. Oh, people still copying. I'll put this over here.
Make sure I catch everything.
Okay. So number 5. So just to remind you guys, the formula for the average rate of change is really just slope. Slope is the average rate of change of some function, right? So if I have a line, the slope is 5, that means for every step of 1, it increases by 5. That's the average rate of change. You guys ever driven around and see grade signs, like 11% grade? So that's like the hill going down, what's that street? Going down from like South Park over to, you know, it goes, whoa! Some of you guys know what I mean. That's like 11% grade, I can't remember what it is.
Like A Street or something.
So that's just a slope. That's an average rate of change. That would mean for every 1 foot you go forward, it's actually every 100 feet you go forward, it's 11 feet down. Because 11% would be 11 over 100. Unimportant right now. Just that's a physical situation of an average rate of change of height. So this is just average rate of change, which means it's y2 minus y1 over x2 minus x1. How do I get y's in general? I plug values into
X.
f for x, yes. So this is the real formula. F of x2 minus f of x1 over x2 minus x1. That is just y2 minus y1. I really want you guys with me. How do you calculate a y if you're given an x? You put the x in, right? So how would I calculate the second y? I would plug the first input in. I would plug the other input in to get the other output, right? So here, what's the second input that it wants me to use?
B.
B. And what's the first input it wants me to use?
1.
1. So the second input is B, the first input is 1. f of 1, you guys should eat up, right? What, can anyone just tell me what f of 1 is?
3.
Yeah, you plug a 1 in, 4 times 1 squared is 4, minus 7 is negative 3. F of b is actually, in a way, easier. What would f of b be? 4b squared minus 7, yeah. So then you just plug those in and simplify as much as you can. Okay, maybe. So average rate of change, this is another name for slope, because that's what slope actually calculates, is how much is this function changing over time.
I think I kind of wrote that down. Well, look at what I got here. But it's like I couldn't go any further.
Yeah, so one thing is this should be in parentheses, because you got to subtract the entire thing, right? So this would be 4b squared minus 7 minus, and we already calculated what this was, f of 1 was negative 3. I just got to simplify that. Okay, maybe.
So would multiplying by the reciprocal kind of get rid of the...
No. Mm-mm. You don't have an equation. You have a single expression. What you're going to do is you're going to simplify the top and then factor. Okay, so let me show you an example. Real quick, you guys. How would you reduce this fraction here? This is going to be silly, nice, easy answer. How do you reduce that fraction?
11 by 3.
Even more.
9.
Yeah. Here's something you would never write. But this is really what's happening. You would never write this. 18 is 9 times 2, yes?
Yeah,
27 is 9 times 3, yes?
yeah.
So the 9's canceled. Now what we normally would do at most is this, yes? And we still get 2/3. Everybody with me?
Yeah.
Okay. So what if I had this? Let me ask you a really important question. Can you cancel an x?
No.
Why not?
Because of the addition.
Yeah, the addition subtraction. Division cannot cancel parts of addition subtraction, right? What's the only thing division can cancel? What operation can division cancel?
Multiplication.
Multiplication. That's what it's built on, right? So what do I do instead? What did we do on this problem? What did we do? What did we do with the pieces? Factor it. So which part can you factor here? Top. How's that top factor?
X minus 1, X minus 1?
No.
Plus 1.
Separate, different signs, so it comes out negative, yes?
Okay.
And the middle term cancels, right? And then what happens there? Why did these cancel now?
Because they're the same.
Because this is times and this is division. So any piece that's the same now can cancel, because division is the opposite of multiplication. Now I know you all know that, but when somebody does this, they cancel an x. No, division can't, it's not something division can do. That's not a power division has. It can't cancel addition or subtraction. But now I've got this times this divided by the same thing, these die. Division can do its job. So that is what's going to happen here. You're going to factor the top, and then you're going to be able to kill something. Okay, maybe. One nice thing about the way I teach is if you hate variables and all that, you get to kill them sometimes, right? Okay. Die. Better. Okay. All right. Let me go through some of these other ones. Other questions people had. So let's look back at 3:1. Let's see. Yeah, okay, maybe I'll talk about that in a minute. 3:1, number 33. It's so weird to see the sun out there. Is it also raining? Yeah. Awesome. Come on, where are you? 3-1. There you go. 33. Oh my God. Where? This guy? Oh! That's funny. It's exactly the same kind of thing we just did, right? Do you guys see that? Whoever asked that question, this is exactly kind of the same as what we just did. Look at what they want me to evaluate. What's the only piece of this expression I don't know? Do I know g of x?
Yes.
Totally. Do I know g of a?
No.
No. Can you figure out what g of a is?
A squared
Do you
plus
know what g of
2a.
x is? Yes. So I can figure out what g of any damn thing is.
But it says x doesn't equal a though.
Yeah, because the bottom can't be 0.
Oh, okay.
I like it. But this is just saying g of a, so plug an a in. I see. So this gets a little confusing, but that's just because the bottom can't be 0. I could put a in the top.
Okay.
Okay. What they really should have said here is x minus a can't be, well, this would be the same thing. It's a little weird to explain, but they have to say this so the bottom's not 0. But then it's a little confusing because you're like, I need to make x a, and you said it can't be. But I can still evaluate this expression. Yeah. Okay. Maybe. Is that what, 3 off?
I didn't ask the question. I
Oh,
was
I'm
just
sorry.
assuming.
Gotcha. Is that all right, guys? That's actually better than what we just did, because it's not x plus h in there, right? That's actually better. So help me out, guys. What is g of x in this problem? X squared plus 2x. So I put x squared plus 2x right there. What is g of a?
A squared plus 2a.
Yeah, a squared plus 2x. So then, again, I'm going to make a mistake. I have made a mistake.
You
I've
didn't
done
put
something
parentheses.
wrong. Yeah, I got to subtract g of a, not just a piece of g of a. And then what's on the bottom? That's right, kids. X minus. And now the top, you just simplify. Now I say that like it's easy, but how many terms are on the top?
2.
2. So maybe there's something you can do up here. Not 2. There's 4 terms. Right.
Oh, x squared plus 2x squared. Okay.
Minus a squared minus 2a. This is going to be an interesting grouping one, right? I'll give you a little clue. If you switch the middle terms, you can do something with it. You can actually factor it. Right? Okay. Maybe. What's really important on this problem is, does everybody see where what I've written here so far comes from? Right? Everybody except the people at home.
How can you switch the middle terms?
You switch them? All right, let's look at that by itself. Okay. Does everybody agree with me? Just looking at the top there, I'm going to write the top. X squared plus 2x, distribute the negative. How many terms are there? I'm just looking at the top. I know there's a bottom. I just care about the top right now. Let's not
4.
look too drum jack.
3.
How many terms are there?
There's 4.
Yeah, how many pluses and minuses are there?
3.
And they separate terms, so there must be 4 terms. 1, 2, 3, 4. What method do I use when I have 4 or more terms?
Grouping?
Grouping. If I leave it the way it is, do you guys see? So I can take an x out here, right? What comes out of here?
Negative a?
Negative a. Can I do the next step?
Yes. Or no?
What is it that tells me I can do the next step is if I have something common. Do I have anything common to these?
Plus 2? Or
There's no 2 anywhere up there. I did not write a 2 anywhere. And this is where you guys go, God, I knew
You've
this
got
guy
an
was
x
off
and an
his
x plus
meds.
2, and an a and an
Exactly.
a plus 2.
I have an
And
x
none of
plus
them
2. What number is
are
that?
common.
I don't freaking know. I have an a plus 2. What number is that? I don't know. I don't have a 2 anywhere. Let me ask you this real quick. Does 8 have a 4 in it?
yes.
Totally, because 8's 4 times 2. Does 5 have a 4 in it?
No.
No! Even though 5 is 4 plus 1, that's not really what I mean by that. It's got to be a factor of it. All right. So can I take a 2 out or something? No, because there's no 2 anywhere up there. If you're still like, Jeff, what's that, Jeff? I understand. 2 is a part of it, but that is x plus 2. That's what number that is. I don't see a 2 up there anywhere. So, there's nothing in this term that is the same as that term. This guy has an x and an x plus 2. He's got an a and an a plus 2. So it looks like grouping doesn't work, correct?
Looks like it.
Looks like it. But if I just switch the middle 2, this is something that happens in grouping sometimes, is they just put it out of order. So this problem just happened to be out of order. There's still 4 terms, of course, right? What can I do with these 2?
You can get the square root.
No. How do I factor it?
X minus a, x plus a.
Okay. And then what comes out of these 2?
2, and x minus a.
Do these 2 terms, everybody agree there's 2 terms? Because there's
Oh,
a
yeah.
plus separating them? Do they have anything in common?
The first one and the last one.
What do they have in common exactly?
X minus A.
X minus a. So what can come out?
X minus
What's left?
X plus a.
X
So you
plus
can
a.
do this for yourself, right? When you're doing the homework, just cover that. You took it out, so it's gone. So there's an x plus a, and then there's a
2.
plus 2. So that's factored. Remind me, that's the top, correct? That's the top of this. What was on the bottom?
X minus a.
What happens?
They cancel.
Yes, because now I got multiplication and division. They cancel. That problem was weird because you don't see a lot of grouping problems where, oh shit, it's just out of order. I love you guys. So, for example, if I gave you this problem here, would you do 1 times negative 6? Would that be your first step? Why not? Because
Well,
it's out of,
It's out of order.
Out of order,
4
okay, good.
squared,
yeah.
4x squared plus
Yeah, so that's got to be first.
x.
And then you would do 4 times negative, right? So sometimes they can give us a problem out of order. We're just like, all right, there you go. So with grouping, you will sometimes have to switch the middle 2. Just because they're kind of in the wrong order. The stuff doesn't go together. Switch it, oh good, now they go together. Okay, I like it. This is good, by the way. Every question you've asked me so far is one of the weirder problems, which makes me feel okay, because as long as you get the other ones, you're pretty good. These problems are a little bit freakier. Okay, maybe. You guys don't trust me, it's okay. Some of you guys just met me a little while ago. Yes? Did I? Wait, I'm sorry. Let me do this one and then that'll finish all of the ones. And then let me forget. Number 18. Here we go. Oh, okay. These problems. Okay. Not very completely inked up hand. The quickest way to tell algebraically that something is a function is just, is it either already solved for y? So how do I know that's a function? What's the definition of function? I'll carry this around.
Only one output.
Yes, so if I put an x, any input in, do you see how it equals one output? It equals y. So if you can solve for y and there's one answer, that's a function. So look at, for example, this problem. What happens if you try to solve this for y? You're going to have to eventually do what? What are you going to have to do right here?
Square root.
And when you square root, what do you have to put down?
Plus or minus.
So every input has 1, 2 outputs. Do you guys see that?
Yeah.
That is one of the best ways to do this section is just, can you solve for y and get one answer? That problem, no. This problem, they already did. Thank you, book, right? Look at this problem. Where's the other one? Down here, look at that problem. Number 24. They already did the work for me. Is that a function?
No.
For just about every input, I get more than one. I get two outputs, correct? I get a positive output and a negative output. That's exactly not a function. Are you guys with me? You don't have to graph every one of those and do the vertical line test. You don't. You just have to see, can I solve it for y? And get one answer. Because that's what function is. For every input, I get one output. Okay. All right, let me stop for a minute. So, what was the question back there? I'm sorry, which ones? Okay. The same section? 3-1? Oh, yeah. We did.
We did it yesterday.
Yeah. We did these. So the idea here is, if my inputs are negative 10 and 10, what would the output be for negative 10? Negative 1,000. And the output for 10? So I would want my range to be this. For these inputs, it generates these outputs. So I want my range. So on the calculator, you would go to Window, and you would make Y min negative 1,000 and Y max 1,000. That would be your range. That would be your outputs. And we did exactly this one yesterday. Yeah. Yes.
Could you go over number 75
75 in
54?
in which section?
3.1.
Oh,
Same way.
this one. This here?
Yes.
Okay. Why was why? All right. Would 74 be easier?
I feel like because of the fraction kind of.
Oh, okay. I was trying to make sure. Is it just the fraction? And you guys are like, that's nice for you, Jeff. Just the fraction. What's the first thing that the function f does? This is going to be a strange question, possible. What's the very first thing the function f does for any input? When I plug a number in to f, what's the very first thing I'm going to do? Multiply it by 3. So why do I not give a shit about that fractional input? I don't care. What was it? 3x minus 2. What's going to happen when I plug this in? I'm going to multiply by 3, and what's going to happen?
You're gonna cancel it out.
Bottom's going to cancel. Not a fraction anymore. You see that?
Oh.
Yeah. So don't immediately give up hope when you see a fraction, because maybe it's going to die. Even if it doesn't, we've got to be able to handle fractions. We just have to be. This one's nice because it immediately dies. Poor little dude. Okay.
Well, the problem that I had with number 5 is.
Real quick, you have a question on this? This one?
It was just asking if it didn't have 3 as a multiple.
Yeah, then you would, so what would f of 4/5 be? It would be 3 times 4/5 minus 2, right? Is that cool? I don't care what the hell that is. My very first step is no work. Whatever that is, you just replace x with it, right? Now I got work to do. What's 3 times 4? How do I subtract 2? I put it over 1. I make an LCD, right? Okay, not a big deal. The problem they gave us was even less of a deal because no fraction up to the first step, right? Okay, maybe. So in general, if I give you a function and say, what is f of weird ass thing? Your first step is no work. You take weird ass thing and you put it in. At least do that. Because then you're communicating to me, I understand what this problem wants me to do. If you then look at the problem and go, I have no idea. At least you're going to get some points for telling me you know what the hell you're supposed to do, right? If you're like, I don't know what to do with that, okay. But you're not going to lose all the points. Do you guys understand? Okay.
I understand.
You can always do the first step of a function evaluation, because it's whatever the shit that is, you put it in. If you don't know what to do after that, okay, you're gonna lose some points, but not all of them. Maybe. The absolute worst thing you can do on anything is leave it blank. And when I say that, I don't mean, hey Jeff, you said not to leave this blank. I've had people do that. No, when I say don't leave it blank, I mean try something. And I guarantee you, if you try something mathematical that makes sense, you won't lose all the points. Okay. So let me say this. Our test is currently scheduled for Tuesday. Notice the way I said that. We are definitely a little behind where I wanted us to be, which is not a huge issue. So, where I wanted to get to before the test was, let me see. I believe I wanted to get to section, just give up, Jeff. Okay. 3-6. Yeah, I don't think it's gonna happen. So let me say this. If I move the test to Wednesday, will anybody be completely screwed by that? Is anybody planning on not being here Wednesday? Okay. Does anyone not like the idea of moving the test to Wednesday? Is anybody against that? You can be against it, it's fine.
What day was it originally? Or was it-
Tuesday, whatever day that is. Is Wednesday Valentine's Day? Yeah? Oh, my little gift to you. That's fine. Aw. Okay, let's do that. Let's move the test to Wednesday, right? Give us a little more breathing room. So we'll move the test 1. Will now be next Wednesday, and that is the 14th, right? Okay. All right, I'll put a little heart on it for you. Aw. Instead of be mine, it'll say do math. Do math, not meth kids, math. Okay. Okay, so anything else? It could even be a question about something we just did. It can
Yeah.
always be a question about something we just did.
I do have it's like, well, I already asked you about number 5, because
Gotcha.
I already got, you, I pretty much had what you had mentioned, but where I got hung up is, I don't know how I can divide that into that, or
No.
simplify.
No. Simplify the top first, and then factor the top. Because then you can cancel the b minus 1. Trust me. So now, do that inside, distribute the negative, put your like terms together. You with me?
Well,
Just simplify the top.
there's-
Do inside the parentheses, distribute the negative. Yeah. Yeah.
Oh, number 30.
In
3.1. What's the negative FFA?
all right. So this, you mean just this part, negative f of a?
just
Okay. So, I'll do one like that. Guys, if I give you this function, where you okay. 4x minus 2 over 7 minus 5x. Okay. Can anyone tell me what g of w is?
4W minus 2.
Yeah! G of x is 4x minus 2 over 7 minus 5x. So g of w is 4w minus 2 over 7 minus 5w. Right, function notation is so single-minded. What is negative g of w? It's negative, and what's g of w?
4W.
All right, so how do I do that?
Distribute the negative sign.
What do you get? Done. Why don't I multiply the bottom by negative also? How many negatives are here? So it can only go to one or the other one. So I normally just put it in the top. Doesn't matter. You guys, is that all right? That's exactly, because I think the question right before that is, the question right before that is f of negative a. But to do negative f of a, just figure out what f of a is and then change the sign. Just do the negative of that. Okay. Yes.
Could you do number 54?
In the same section?
Yes.
Oh, okay. All right. So this problem might be freaky at first because do they give us a function? Do they tell me what f is? Do they give me the actual mathematical function? Is it 3x minus 7? Is it x cubed minus x squared? I have no freaking idea, right? So then on first glance, some of you guys may be like, well, Jeff, it didn't tell me enough shit. I'm not going to do it because I don't know. They gave me something better. They gave me something better. They gave me all the freaking answers. They already did all the work. So I don't care what the function was. Where did they put the point? What's the input in this question?
4.
Where is the point at 4? Yeah. For an input of 4, where's the output? Negative 3. Done. Done. Whatever f was, when they put a 4 in, what did they get out? Negative 3. Done.
Is that right?
Just a minute. No? Are you guys all right? No. Look at this one. What is f of 0? When they put a 0 in, where did they put the point? Because you would put the point where the output is, correct? So when the input's 0, what's the output?
1.
Done. The output must be 1, because that's where they put the point. They already, what does the graph tell you? The most basic thing a graph gives you is all the answers. If I give you a function, don't you have to make a table of values and you plot the points and you connect them? You are giving me all the answers. They already did all that work. They did all the work. Yeah.
What about for B though?
Oh, okay. I want you to realize this, one way to make this a complete statement is f of 0 equals what? So it's really just asking what's the output when the input is 0? Yes?
Okay.
What is this one saying? What do I know? Do I know the input or the output?
The out.
I know the output. When is the output negative 3? What input? I swear to God, Steve, every time.
Okay.
I love Steve.
It's
Doing some
2.
real damage to the floor.
I know. Oh my gosh. All right.
So there's
Is
two answers.
everybody with me? This question says, okay, I'm going to tell you the input's 0. I just want to know what the output is. That's easy because they gave me everything, right? This one's saying, okay, we're going to give you the output's negative 3. What input? So where am I looking for the output? I want an output to be negative 3. There are 2 answers. Do you see that? What input gives me negative 3 output?
Negative 2 and 2.
Yeah, negative 2 and 2. So this would be, so you can do the same thing over there. Yeah?
Okay.
Does that make
Got
sense?
it, yeah. That makes sense.
It's just you're not used to seeing this kind of thing, but this is really hammering home what you're doing when you make a graph. You're providing somebody with all the damn answers in the easiest way. I don't want to make a table of all the answers. That would take an infinite amount of time. I'd rather just give somebody a graph and say, go find whatever answer. What about 5? Keep going. Leave me alone. I got stuff to do. Yeah.
So we did 2 outputs then, right? You gave 2 and 2?
No. 2 inputs. So what makes the output negative 3? Either negative 2 or 2. That's why they're both answers. Yeah. Cool.
So for 54, you could do negative 6 and 0 for the.
Yep. I was trying not to give it away, but you got it. Yeah. It's the same idea. Just go, what makes the output 2? Where am I going to look for 2? Am I going to look here? based on what I just said, what makes the output 2? What makes the output 2? Where am I going to find 2? What axis? Output is 2. So where am I looking here?
Oh, you're looking on the
No.
I'm looking
y.
at the output. So what input makes the output 2?
Negative one,
And?
negative five.
Ah, so the answers would be -1, -5. You're just saying what input do I have to get put in to make the output to make the output 2? Hey, I can just see them. I don't have any work to do because they've already done the work. They already did all the answers. Another way to ask this question is complete this point. Do you guys see what I mean? What point does the graph go through that has a 2 there? Well, it goes through the point -5, 2 and -1, 2. So it's the same question, really. Okay. All right. So let's see. Last time, I believe the last thing we did. Oh yeah, the very last thing we did was I teased transformations. It's like I gave you the teaser trailer. Okay. Before I keep going, anything else? So I appreciate those of you I've seen. I don't get in the math study very often, but I've seen a few of you guys in there. And that is a remarkably smart thing to do because it's free and it's safe and it's populated by a bunch of people that love math.
Did I get that right?
Oh, I'm sorry. Oh, yes. Wait, no. You oversimplified. Does this guy have a B? Does that guy have a B?
No, he doesn't.
So you can't take a B out. Yeah. But you get the right kind of idea. Just factor correctly. It'll still work. All right. Okay. So, I think one thing I did last time is, let's do this really quick. If you just had to give me the idea of x squared, we already talked stability and so on. What does it look like? Yeah. Okay. Anybody else draw in the air? All right. I like it. And you're all like, I ain't doing shit for you, Jeff. All right. Okay. So let's do that. Now, I need you to understand, in the homework, if it says graph this function, that is no way in freaking hell, right? Even if you do this, no. I need points. I need to see some work, right? You can always check your work with the calculator, but I don't know where the hell it came from. I need to see some work, some points, right? Now you should know what this looks like. Anybody remember what this looks like? I did that one last time. Yeah. Looks like some competitor in Nike. It's their symbol for their shoes, right? Okay. It also looks like a parabola that fell down and then lost its bottom part. Poor little dude. Why does that make sense? Are square root and squared connected? Or are the square root and squared functions connected somehow? What do they do to each other? Cancel each other out. So they're what's called inverses of each other. So graphically, they should have a connection. You guys kind of with me? If two functions are connected mathematically, there should be some connection graphically. So sure enough, if I just turn that and have the bottom fall out, I get that. Also, just to prepare us for a little bit, does anyone know what that looks like?
It's like
B.
Yeah, how do I investigate that? What's the absolute value of 1? 1. What's the absolute value of 0? 0. What's the absolute value of negative 1? 1. What's the idea of absolute value? Does anyone know? Why is the absolute value always positive? What physical idea is absolute value based on? Does anyone know?
Isn't that the difference?
Not difference.
Parallel? How many points away from 0 to 1?
Okay, distance. It's based on distance. You with me? Yes?
I was gonna say how far away it is from 0.
Good, so it's the distance, right? Now, for example, Mike is about 2 feet away from me, maybe 3. You guys all with me? If I turn around, he's not -3. If he was -3 feet, he'd be like, Quaid, right? That'd be weird. It'd be some black hole kind of thing. So distances are positive. So how far from 0 is 1? 1 step. How far from 0 is -1? 1 step. So the absolute value, that's why it always comes out positive. What's the only number that the answer is not positive? 0. I love it. So this looks like, it's not curvy. How do I know this will not be curvy? Why is this curvy? And this, by the way, but why is this curvy?
Because there's an exponent.
Because the power is not 1. This would be a 1/2 power, remember that? That's not 1, curvy. Squared, not 1, curvy. Absolute value of x to the first power, it will not be curvy. So it's going to look like this. Can we stop for a minute? Does anyone remember that? That's what an absolute value looks like?
Mhm.
Real quick, x squared and the absolute value of x. Neither one of them can have an output that is negative, if I use real numbers. In general, we're always using real numbers unless I specifically say we can use complex. So if I use real numbers, neither one of them can come out negative. So that's why they both, oh, I'm approaching negative, oh shit. He's got to turn. This guy is like, oh shit, I'm approaching that, but it cannot go below the x-axis because the outputs can't be negative. Either one. This one's curvy because it's squared. This one's not curvy because it's not squared. It's only to a first power. Okay, you guys with me? So throughout the semester, we're just going to add to our repertoire of what functions look like. Here's one big reason why we want to do that. Would you want to have to create an entire table of values for every damn function you could come across? Do you want to do that forever? I don't either, good God. So the better we know the shape of a function, the more we should be able to kind of like skip that step. So here's what we did last time. What would it be if I made, and I'm going to run out of letters, let me use capital. What if I use this? What would happen for this function here? What do you guys think? Visually, what would happen? Like that picture is this, yes? So every output is the square of the input. What does this function say I want to do to every output? I want to take 1 away from every output, correct? You guys see that? There's that function up there, and then I want to take every output down 1. So what's going to happen visually?
You're going to slide over that?
No.
It's gonna go down 1.
I want every output. So what's the output here? Now I want it to be 1 less. So it's going to take every point and move it down 1, move it down 1, move it down 1. So it's going to shift down 1.
Okay.
So look at it, because I can find that function here, yes? So I want that function, put 1 lower, that's all. So what if I would have put +2?
And it would go up to.
It would go up 2. So if I give you a problem and I say graph this using transformations, I will often say graph the base function first. So what do we just identify as and I just said a word, transformation is just what we call moving freaking functions around. We can also squeeze them, we can stretch them, we can flip them, right? We can do all these things, we just call all that transformations. What did we just say that this is? It's well, how would I move this function? Downward. So I say list the transformations. What's the base function would be, what is it without the transformation? It would be this. You can do it, Jeff. Why do I make it dotted? Because it's not the answer yet. Yes?
How does it go when it's like inside the parentheses?
We'll see in a minute. Do one at a time. But you're good, you're good. So now what do? The beautiful thing is once you graph the base function, this point, how does it move? What did we just say? It goes down 1. This point, how does it move?
Goes down.
No. This point,
Goes
down 1. And then you just connect those points, make that big.
And now we draw it solid because it is the answer.
Yes. So let's test it. What's one point that my function goes through, my new function? 1, 0. So it goes through the point 1, 0. When I put a 1 in, what do I get? 1 minus 1? 0. Kick ass. So you can always check your work by just picking your point, plugging it in. How we doing so far? Doing okay? So real quick, what if, so there's just one transformation there. What if I had this function then? So let's graph this a little better. 0, 0, here's the base function. 0, 0, square root of 1 is 1, square root of 4 is 2. So we graphed this one last time. You guys with me? So here's the base function. Oh shit, I didn't give myself enough room. Can y'all just make this a +1, please? Mark.
It's just gonna go up one.
So now I'm going to take every point and just put it up 1. Please let that be like, oh, okay, sweet. Right? You just have to know what the base function looks like, and then this point goes up 1, this point goes up 1, this point goes up 1. Connect the dots with the same shape. Make them bigger if you need to. Bam! What point is this? Yeah. You gotta give me board license because I'm like right on it. 4, 3. Are you with me? What's the square root of 4?
2.
Plus 1.
3.
Hey, it checks. Okay. So far, so good. Okay. Same thing would happen with the absolute value. You can move it up and down, right? So the question is, what happens if I put a number inside? And that's something we did last time a little bit. So has everybody got what they want here?
It's in there, right?
Yep, it's in there. So we'll be on YouTube later. Let me erase that much of this. Okay. So what if I make this? What you got, John? Let's graph the base function. So the base, now real quick. What's the thing I added there? What new thing in top of the base function? The base function is x squared, right? So I added the +2, yes? If I just cover up the +2, isn't that the base function x squared?
Yeah.
Okay. So if I graph the base function, 1 squared is 1, 0 squared is 0, -1 squared is -1, there's the base function. You can always graph the base function. Now the question is, how the hell does this move?
Left or right?
So this, do you see how the +2, do you understand? It's not affecting the outputs. Because what is it with?
VX.
It's with the x, so it's affecting the inputs. When it's outside, up or down. When it's in with the x, left and right, because the freaking x-axis goes left and right. Okay. So tell me this. What number did we put in there to make the output 0?
0.
0. What number do we put in here to make the output 0?
-2.
-2. Right? You guys with me? So every input, I really want this to make sense. Every input can now be 2 less than it used to have to be. So an example I give is, let's say you're going to a bar and the cover charge is $2. And you're walking up and you got no money. Are they gonna let you in? You got no money, right? And you don't know anybody there. Get away from here. Let's say there's a guy at the door that's just like, just won the lottery. He's just like, I'll cover your cover charge. Here's $2. I'm gonna give you $2, right? You with me? So now you can get in the bar, right? So now I can have 2 less dollars than I needed before. Every input is now going to go back 2. So help me out. What do I get when I put a 0 in here?
Cancels out.
The inside is 2, yes? When I put a 0 in here,
Oh.
Got -2.
I get a 2 inside. What did I used to have to put here to make it 2? 2, yeah?
Yeah.
So now it could be 2 less because the very first thing I do to any input is I add 2 to it. I give it a couple bucks. They can all be 2 less than they had to be before. All right, let's make this a little more realistic. Go to a bar, the cover charge is $10. I come to the door, I have $8. Are they gonna let me in? No. That nice guy is still there. Here's a couple bucks, man. Can I go in now?
Yeah.
So in general, in the bar, I need $10, correct? If there is somebody standing at the door giving $2 to everybody, can everybody now come with $8 and still get in?
Yeah.
Yeah, they can all come in with 2 less than they had before, right? So this picture, what's going to happen to the picture? So it's not outside, it's inside. So left and right, it's actually going to go back to 1, 2. So this is what's weird. When it's inside with the letter, it does the opposite of what it looks like. Because now all my inputs can be 2 less than they were before. How did I get an output of 1 right here in the original function? I put a 1 in, correct? Are you with me? How do I get a 1 here? I put a 1 in. How do I get a 1 in here now? How do I make this 1? What do I put in for x? Negative 1. 2 less than it had to be before. Because the very first thing I'm doing is I'm giving it 2. So this output goes back 1, 2. This goes back 1, 2. There's the new function. There's the translated function, right? What point is this?
There's 1.
Negative 3, 1. Let's check it. Negative 3 plus 2 is? Negative 1 squared is? Kick ass. Maybe. All right, let's try square root real quick. What about? If I do big ass G check. This guy's got problems. What was the lowest number I could put in the original function? Lower than that. 0, right? What happens if I try to put 0 in here? It becomes, what happens when I put a 0 in for x? I get negative 4. Do you want to graph complex numbers? Do you want to do that weird shit with the color shit? No. So you guys might want to. That's awesome, but no, it's not. Do you guys understand? The very first thing that's happening is it's taking 4 away from me. So if it costs $10 to get in the club and I got 14, and somebody steals $4 from me, I can still get in the club. I need to have more money than I did in the first place. If somebody's going to steal $4 from me, I better have $4 more than I needed before, because I'm going to lose 4. So to overcome this minus 4, every input has to be 4 bigger. So the base function is square root of 0 is 0, square root of 1 is 1, that's crazy, Jeff, and the square root of 4 is 2. So there's the base function. Let me put this over a little bit. The board is always weird. This translation is move right 4, because every input has to be 4 bigger than it used to be. What do I get when I put a 4 in there?
You get 0.
You get 0. So now instead of 0, 0, it's now 4, 0. Every point moves over 4. You're going to need more stuff, Jeff. Okay. So now it's going to look like this. And watch what I'm doing. I'm not doing any work really. I'm just saying, okay, there's a point, move it 1, 2, 3, 4. There's a point, move it 1, 2, 3, 4. There's a point, move it 1, 2, 3. You know, 1, 4. Can I count? Who knows? And then you just draw the shape it. So I just physically lifted it and put it. Maybe. So here, you guys try this one with the absolute value. Stay with me. Try to graph this function. So I've given you the base function. So now you want to dot it, right? Graph this. So graph the base function, make it dotted. and then move things the correct direction.
It's gonna have to go to the right.
Maybe. Yeah.
How do I type the little like border things on your calculator?
Oh, neato. I'm not gonna tell you. Not yet, anyway. Oh, Jeff, you're so mean, Jeff. Again, I got an A++ in my evil math teacher class. At the moment, I don't want you even to know how to do that. Because you know the shape. You can do this, right? And then I'll tell you in a minute, okay? My math teacher's an asshole. I'm gonna tell you, I'll tell you. In fact, I already told you guys, but I'll tell you again. Can somebody tell me how this is gonna shift?
Right.
Yes, why is it going right to? It's the opposite sign. Whenever it's in with the letter, it's the opposite. Why is it gotta be the opposite? Because don't all my inputs have to be 2 bigger than before? Because the very first thing some asshole's doing is taking 2 away from me. So before I put a 0 in to get 0, now I've got to put a 1 in to get 0. 2, I've got to be 2 bigger than I used to.
Okay, so your base thing would be that, but wouldn't it wind up having to go positive anyway because it's an absolute value?
No. My inputs, aren't some of my inputs negative?
Yes.
Couldn't I move this backwards? Couldn't I just pick this
yeah,
up?
you
and-
can move the graph.
Yeah, so this is moving the graph to the right too,
Yeah.
right? Because every input, so the weirdest thing for students is why don't we go back to, Jeff? It's freaking minus, Jeff. What the shit? Because my inputs have to overcome losing 2. They all have to have 2 more dollars than before. Because the first thing somebody's doing is taking 2 away from them. Damn it! So this guy, before he needed no money, now he's got to have $2. This guy moves over 1, 2. This guy moves over 1, 2. Put the shape in. Done. What point is this?
So 4-1.
3, 1. When I put a 3 in, I get 3 minus 2 is 1.
Yeah,
Absolute value 1 is
I can't see.
1. You can always check your work.
Okay. I was guessing because you were standing in front of
Oh, okay.
me.
Those points are 1, 1, right? Positive 1, 1, and negative 1, 1.
Oh, here for the base?
Yeah.
Yeah, because absolute value is 0 is 0, absolute value 1 is 1, absolute value negative 1 is 1. Yeah, so you can always get that base sucker done. I almost always use negative 1, 0, 1 as my base. I call them my anchor points, but you don't have to. That anchors my base function in place. So, the ultimate thingamajig. What if I did this? What are you going to do, Jeff? I don't know. What's up?
You want me to answer?
Yeah. How many transformations are happening? 2. I love it. What are they? In fact, here, just to help you out. Here doesn't matter as much, but in general it does. So I tell people to do this all the time. Order of operations. Do it that way. What would the first thing you would do be? If I plugged a number in, what's the first thing that would happen? I would add 1. So I do that transformation first. So that's left 1. Is everybody with me?
Yes.
Left 1. If it's outside, it's because that would be a parabola that's moved back 1. And then what do I want to do to every output? I want to take it
Down 3.
down 3. So when it's outside, you do exactly what it looks like. Because it's affecting the outputs directly. When it's inside, oh shit. That's where you have to think, oh man, I gotta do the outputs. Very quickly, I don't know if this is gonna help anybody. But remember what was here before, of course? It used to be a Y, right? You guys with me? Watch this, watch this. Couldn't you add 3 over if you really wanted to? Why is that left 1? Because the plus 1 is with x, correct? It's inside with x,
Yeah.
so it does the opposite of what it looks like. Is the 3 with the y now? When it's with the letter, it does the opposite of what it looks like. You guys at all with me?
Oh,
So that, you don't have to do this, please dear God, you do not have to do this, but I want to show you, because one problem a student might have is, why is this shit not consistent, Jeff? Why do you sometimes when you see a plus 1 you go up, or sometimes you go back? What the shit? Because if I put the -3 over there, it's not with its letter. Now, you don't have to do that. You can just memorize that that actually just takes that down 3, just very directly. This, oh man, all my inputs can be 1 less than they used to be, because the very first thing I'm doing is giving them 1. So this left 1 and then down 3. Real quick, can somebody tell me where the vertex is on the base function? 0, 0 is the vertex. Okay, I like it. So, if I graph the base function, like we just did, but let me do it again. 0, 0, 1, 1, negative 1, 1. There's the base function. Let me give myself a few more things. Okay. Stay with you now. What do I do to this? I go, so I take an output and I go left 1, and then down 3. 1, 2, 3. My scale sucks, but I won't do better. Taking the next output, or the next point. I'm going to move it left 1, down 1, 2, 3. Next point, left 1, down 1, 2, 3. So now my parabola is there. Where's the vertex now?
-1, 3.
-1, -3. Can you see the vertex -1, -3? Let me do this again. See how the vertex is at -1? Because I start at 0, 0, go back 1, down 3. Yes. Who had a hand? Somebody?
Yeah, I was gonna ask you.
Oh, good. How you guys feeling right now? Yeah?
I have a quick question about the absolute value one. So is it just going up, 1 over, 1 up every time?
Oh, you mean the base?
Yeah.
Yeah, real quick. If x is positive, if I put a positive number into an absolute value, does it do anything? No. So for positive x's, this is just x. Does everybody agree with me? What's the slope of that? 1. It's 1x, right?
Okay.
For negative x's, it has to change the sign. That slope is -1. Negative 1 slope, and then a 1 slope.
Okay.
Yeah. I like it. Yes. Oh, through 3, 6. Yeah, so. Yeah, dude. So right now we're doing section 3.5. Next time we're gonna do that 1 chapter 2 piece in 3.6. Yeah. Yes.
So I see that like section 2.6, like further down the chapter 3, does that also get turned in, or is that like just?
Yeah, where do I have that? It's right below
It's right below 3.6.
3.6. Okay. I'll think about it. We'll see what happens on Monday.
And number 2.1 is on chapter 4.
Say again?
Section 2.1 for chapter 4, is that 2.1 for chapter 4 or 2.1 for this chapter?
Is it listed after the test or before the test?
After.
There you go. So it's not going to be on the test yet. Yes.
So are we going up to 3.7?
Probably not. So I'll adjust the content to it. So there's everybody. All right. I forgot what I was about to do. So let's go ahead and end it. Real quick, I will go ahead and give you the practice test because I already made them. So then you can look them over this weekend. This, by the way, don't turn this in. I'm going to give you the answer key on Tuesday. This is just a little study guide. So you don't even have to look at this. You can make a little paper airplane out of it, throw it away. It's just to help you study. Say again? Yes, please. Oh. a good weekend.
Is there any
Yes.
stop